Welcome everybody to this class about adoption and expenditure on e-commerce, evidence from pool and panel data in Spain. This is part of a bigger project that I will talk about later, and it is done by a team including Ángel Valarezo, Rafael López, myself, Teresa Garín Muñoz, and Íñigo Herrera García. This team has been working for quite some time on a big data set of the National Institute of Statistics of Spain, and we have been doing several works, of which I'm going to tell you today about some of them, but just a few of them. The outline contains the introduction first, the overview. We will see some penetration rates and their evolution. We will also see a brief international comparison. Then I'm going to present you the microdata that we have, the theoretical and empirical models later in point number 4. Point number 5 contains the empirical results. Number 6, the conclusions, and then I'll show you some references in this literature, which is a very vast and important branch of literature in telecommunications. The first question here in the introduction is, why do I talk about e-commerce? And the reason is that it is very important. E-commerce is one of the main services that you can get from internet, and it is crucial because it has an important impact on the disabled, rural, poor health, and people who have time constraints. And in this particular case, e-commerce is also important because it is instrumental for achieving one of the main goals of the European Union, which is understanding and promoting the usage of e-commerce. E-commerce is instrumental for obtaining a digital single market and avoiding social exclusion in the European Union. Here we focus on e-commerce in Spain because we have low penetration rates, and it is always been pointed to the Spanish government by the European Union that it is necessary to improve and foster the penetration and the use of e-commerce by Spanish residents. The models of adoption and expenditure that I'm going to talk about are going to be estimated from data using both panel data and logistic and order logic models. The situation in Spain that I'm going to talk about now in the second section is the following. You see in the green line the internet used by individuals in Spain, and in the other line, the orange line, e-commerce used in the last months in Spain. So now if you look at this, you see that while the penetration of the internet e-commerce is 85%, only like 50% of the people use, and not necessarily very intensively, e-commerce in Spain. If we want to compare this to the situation in the rest of Europe, you see that in this graph we have the penetration rates of e-commerce in the European Union 28 countries as a percentage of people aged between 16 and 74 and for the years 2007 and 2017. And right now, at this moment, we have the data and we are working on the equations for the period 2007-2019. But for the moment, I'm going to show you what we have. In this particular graph that we see in figure 2, you see that the red bars correspond to 2007, while the blue bars correspond to 2017. If you look at the bars from the left-hand side to the right-hand side, they are ordered by the level of penetration in 2017. You see that Spain is the middle range, and it is in where it says Spain, it is 50%, as we saw before, and it used to be 18% in 2007. So now you compare that situation, which is lower than the EU average, with the countries that we would really like to look like. We would like to be like other parliamentary monarchies, like the United Kingdom, Denmark, Luxembourg, the Netherlands, and those are the countries that go in the first places, and we should compare our situation with their situation, and they are like 30 points above us. So they are really ahead of us. Of course, it doesn't make much sense to compare ourselves with countries that are quite low-income countries or countries that have a very little level of development in telecommunications. So what you see in this graph is that Spain has increased the penetration from 18 in 2007 to 50 in 2017. And that is clearly insufficient if you compare it with the first 5 countries, say, in the left-hand side. So we have improved quite substantially over time, but not enough. To be able to do some kind of numerical study, we need data. And the data that we are going to use are the microdata from the survey on equipment and use of information and telecommunication technologies in household, ICTH survey from 2008 to 2017. As I say, we have already 2019. And it is done by the Spanish National Statistical Institute. This same survey is performed in all the countries of Europe, and they are performed using the methodology of Eurostat. They are reported in several publications of the European Commission, and they are homogeneous and comparable across different countries. Of course, within the countries also. It is important to know that not only the methodology is common, but also it has an elevation factor that allows the researcher to know how many different households are being represented by a given point observation, and that is going to be very useful for elevating the sample to represent the population. Let us see now some individual penetration rates of e-commerce in Spain in this period. Notice that sometimes I say 2008, sometimes 2007, and that depends on how the data have been used. So in some places we do have the data on 2007, in some others we don't, and so that's why this changes sometimes. So the first thing I would like you to look at is different dimensions across which the e-commerce may vary. So we are going to look at the heterogeneity that we have in the sample to be able to characterize different behaviors within the sample. The first heterogeneity we want to look at is gender. We see the female and male definition there, and see that the female and male penetrations were quite different, 14.2 and 20.5 in 2008, but in 2017 they are 41.4 and 48.5. So there is still a difference in behavior in those two groups. If you only look at age instead of looking at different genders, if you look only at age, you would see the penetrations that are changing along the age of the people in the sample. You see that in 2008 it started at 25, and then it went down to 1% with people that were 65 or older. Nowadays, or more or less, more precisely, in 2017, the penetrations go from 64% to 9.3%. So they keep decreasing with age, but now the figures are higher. Absolute figures are higher. If you look at education, you would guess ahead of time that the more education people have, the more penetration they have of e-commerce. And that is usually typically the case. If you see that in 2008 that was 1.4, and then it came up to 42.6 in the case of master or PhD person. Now, if you can go to the 2017, you see that the penetration has increased dramatically for the primary studies persons, and also has increased for the master or PhD. So this is a pattern that we are beginning to see, that there are patterns in the sample that are that mean that the behavior of the people is different depending on their characteristics. And this is typical of most economic phenomena. You see now that the digital skills, which is one of the several variables that we construct and that go from low, medium, high, and very high, those are here corresponding to penetrations of 9.8 to 69.2. They are vary a lot across the different levels of skills, and they are interesting to notice and to see what is the pattern of development here. If you look at 2017, you see the same type of pattern, but with higher levels. And again, if you go to the habitat variable, you will see, in principle, you would expect that people from large cities, like the first category here, would make more e-commerce. Or you could guess that the people from the rural areas, you should make more e-commerce because they don't have enough supply close to them. So whatever you may think about this. The data tells you that there is a positive relationship with the size of the population, and that is consistent across years. If you look at household members, you see also things that I'm not going to go into in detail. And the employment situation, again, is essentially telling us that if people are employed, they tend to use more e-commerce, and about the same as if they are students, but more than if they are housekeepers or other categories or retired. And then if you go here to the next characteristics, nationality, there is some difference in favor of Spanish nationality, and there is an income effect also, because we have categories of low, medium, high, and very high income. And if you see, again, the people that have higher income tend to make more e-commerce. Again, if we continue with geographical determinants, you see that there are some communities that tend to make more e-commerce, like Catalonia, Baleares, and then Madrid, and that is typically the case here. Typically, the more rich autonomous communities tend to make more e-commerce, and that is the general shape and the general information contained in this table 1. Table 1 is telling us something that is, we have heterogeneity, and if we characterize the heterogeneity using the variation of different possible determinants, then you see that there is that heterogeneity leads us to think about some possible hypotheses, like income seems to be positively related to the e-commerce, which is a sensible hypothesis, but we don't know for sure whether that is the case or not, because now here we have essentially correlations from one variable, e-commerce, to each one of the other possible variables. The correlations are suggestive. They make us think of possible relationships, but they don't prove anything, because we would have to do a multivariate analysis to be able to really say which variables are important, which ones are not, what are the signs that we estimate, and what are the coefficients that we estimate, and also which are the t-statistics. So this table is very suggestive, but it does not tell you the last word. There are a lot of things, a lot of characteristics, a lot of statistics that are not known when you just look at this table. You need to do the multivariate analysis using a behavioral model and a sample and econometric techniques. So that's why this is very nice, but this is just not enough. This is not telling you something that you can really sell to anybody. Now I want to show you a little bit about the different graphs that I can draw based on the previous table, and the graphs just tell you in a visual way what are the differences in penetration for different groups. I just selected like education, digital skills, employment, and income, and you see that 3 of them are clearly increasing. The other one that depends on how you order the different employment situations, and see that for education there is an educational gap, and the gap continues a long time. You see that for the digital skills, there is also a big gap between low and very high values of digital skills, and the gap continues a long time. And also, if you look at income, you see that there is a income divide, that it is called, and the income divide continues happening a long time, as you can see visually. Of course, these graphs are just to show you how things look like, but this is not proving anything. It's not even measuring anything. It's just giving a first sight of what we have in mind here. To be able to organize the data we have for us, we would need both theoretical and empirical models. We need a theoretical model that is explaining the behavior, and also an empirical model in which we can use as a basis for estimation using observed data. There are several previous models of adoption of new technologies in this particular area. The theory of reasoned action, TRA, of Axen and Fishbein in 1980. This is one of the possible models. The other one is the theory of the planet behavior, TPB, by Axen, Davis, and Davis et al. And then technology acceptance model by Davis and Davis et al. You see, these are behavioral models in the field of psychology, and they are very useful depending on what you want to do with them. But here we are going to use econometric models that are well established in the literature, and in particular case we're going to use discrete choice models that analyze the choices made among a finite set of alternatives by rational individuals constrained by a budget. The discussion that continues right here is going to follow the Nobel laureate in economics 2000, Daniel McFadden, and it can be derived from utility theory and are useful because they give a precise meaning to the probabilities P sub I. This transparency, e-commerce adoption, is an schematic way of presenting the model for analyzing how people adopt e-commerce and what are the main reasons for doing this or not. In the upper left-hand side, you have yi that can be equal to 1 or 0, depending on whether one does buy through e-commerce or not. The utility of buying must be greater or equal to the utility of not buying for the decision to be one, that is, do buy, and otherwise the decision is not to buy. See, yi equals 0. This is a model which is based on utility maximization, and the idea is that the decision of buying or not buying depends on the characteristics of the goods and the characteristics of the persons involved in the decision. So that is why it says U of I equals F open parenthesis beta times Z I close parenthesis plus epsilon sub I. Here, the vector beta of coefficients of the observed variables. So that is a way of summarizing the strength with which every variable is going to impact on the decision of buying or not buying. Epsilon sub I captures the impact of all unobserved factors that are not explicit in the equation. Xi is a set of attributes of the different alternatives that the consumer is considering. S sub I is the attributes of the person, so that would be the age or the education and the location. And then Zi are observed variables relating to person 1. So that depends on the attributes of the alternatives, also X1. They interact. And those are probably interacted with attributes of the person Si. So the Z's end up being a function of X's and S's. So that is a very synthetic way of talking about this type of utility maximizing framework. And the idea is that the dependent variable here is the discrete, is yes or no. And the idea is that we are going to measure the adoption of e-commerce being 1 when the individual has bought online for private use in the last 12 months and is equal to 0 otherwise. The model here is a model conditional of being internet user. So if you're not internet user, you cannot make the decision of buying or not buying online. Here, the independent variables that we are considering, so that would be the explanatory variables, would be the gender, which we are using 2 groups. 1 is equal to male, 0 is female. Age, we have 6 groups that we saw in the previous table 2. Education, 4 different levels. Digital skills, 4 different levels. Habitat, 4 groups that we saw also in the previous transparencies. Household members, 5 different groups. Nationality, 2 groups. Then employment situation, 6 groups. Income, 4 groups. And then we also use yearly dummies, 1 dummy for a year. And then regional dummies, we have 17 autonomous communities plus 2 autonomous cities. And so that would be the data. The data is gathered from the National Institute of Statistics, and there is a lot of transformations involved because the levels of study are more than 4, and then the income comes in euros, and we have to put it into 4 different groups, and all these variables need a lot of transformation until being useful for a numerical modeling that we are using here. In this particular table 2 here we have a e-commerce model, and we have estimated it using pool data and panel data. The 2 estimation techniques are different. One is just ordinary least squares. The other one is usually allowing for different constants, and it is either fixed effects or random effects depending on the situation. In this particular case, we'll see what it is. And in this case, it is useful to notice that the layout of the table is very similar to the previous layout. And now it is quite a different thing because this is a multivariate setting, and we are taking into account the partial effects of each of the different explanatory variables on the decision. So this is not a total effect, but it's a partial effect. This is the way in which we would like to think, and the way in which we can say that there is some causality from one variable to the other, and taking into account that there are also other variables that intervene in the relationship. If you look at the columns 1 of the table, you have the e-commerce adoption pool data and e-commerce adoption panel data. We are using here odds ratios that essentially tells you what is the effect of one variable or one category of a variable on the outcome, and it is measured starting from 1. So 1 is neutral effect, and then higher than 1 is a positive effect, lower than 1 is a negative effect. I'm not going to go into the details of this because we're going to jump into the graphs. But before the graphs, let me show you what type of sample we have. We have a pool of 76,000 observations. The world test, which is the test for joint significance of all the independent variables, is 10,500, so it's very high. And the degrees of freedom is 70, so that means that we have, of this test, we have 70 independent variables, and the idea is that the more independent variables you have more difficulty for estimating it. But in this particular case, the 10,500 value of the wall test is high enough so that you can be happy with this. The pseudo R-square is like an R-square. It's like saying that we can explain like the 28% of the variation of the dependent variable. And it says also that if we want to compare it and the classification of based on the sample and the sample itself, it's 75% of the time is correctly classified. Then the panel, you may be more familiar with the panel. We have a number of observations which is smaller than before because we don't have data for 2017 in this particular paper. And the wall test is also very high, it's 7,900, so it's very high. And the degrees of freedom is very similar, it's just one less because of the constant. Okay, so let's see now what we obtain in terms of qualitative results. The idea of using panel data is because you want to control for an observed heterogeneity. So we get, with the panel data, we get consistent, efficient, and robust estimates when using the appropriate techniques. The idea is that the model is, the panel data model is jointly significant. Everything is significant also individually. Some variables influence positively the relationship, the adoption decision, and that is the male, education, digital skills, being Spanish, employed, income, digital skills, time age, which is a interaction that we used also, but I'm not going to talk about the interaction now, and the year. So there are some negative variables that are negative, like age and household members. So some are positively related and some of them are negatively related. Of course, if we define the variables in a different way, if we define Spanish as the opposite, then it would have an opposite effect. And again, if one uses the years in different ways or define the gender variable for male being female, it would change. But it changed numerically, but the conclusions are exactly the same economically, and it doesn't make any difference whether you code one variable like 10 or 01. It doesn't matter. And then another variable that comes out irrelevant is the habitat. The habitat doesn't seem to be really important for affecting the results. And then some regional dummies stand out, like Baleares, Catalonia, Madrid, Navarra, and Basque Country, and those are different regions that behave differently based on our data, and that may be due to capital endowments or some other reasons that are collective but not individually measured. Now, if we look at some of the graphs here, in these graphs, they are represented the coefficients estimated in table 2. Those coefficients are what you see here. You see, with respect to gender, you see that the gender in the pool and in the panel estimation, the pool is the blue and the panel is the yellow, then those are pretty much the same. But if you go to the male estimation, then you have a higher effect if you estimate using panel. That makes sense, and that happens many times because in the panel case, we are taking into account the individual heterogeneity. We are not leaving it out, and therefore we are able to estimate with more precision and consistency than in the other situation. If you look at nationality, nationality is very similar also, and nationality, it tells you that if you are a foreigner, you have a 1 effect, so the foreigner is the base effect, no effect, and then the Spanish has a positive effect, which is bigger if measured in the panel. Then again, if you go to the employment situation, this is something that is less clear because it is coded in a different way. It is not 0, 1, but in any case, it is clear typically that if you are employed, you tend to make more e-commerce, and if you are unemployed or you are a housekeeper or anything, you tend to do less e-commerce. And then the income is always important. Income is a very important variable for all economic modeling. And you see that income is positive, has a positive effect the more income, the bigger the effect is on e-commerce. And you again see that if we only look at the pool, we are not aware of the existence of individuals that are repeated in the sample and they have a time dimension. If we are not aware of that, we are in the pool. And then what we have is estimates that are smaller in absolute value than in the case of taking advantage of the panel structure. Again, if you look at the other variables, for instance, age, in age, you see that the more age, the less effect it has on e-commerce. So, older people do less e-commerce. Education is the same, but the opposite sign. The people who are more educated tend to make more e-commerce. Then the digital skills is the same. The people that have more digital skills tend to do more e-commerce. And then there's an interaction that I'm not going to talk about today. Then if you look at figure 6, you see the effects of the different regions. You see that if for the moment we forget about the blues and the yellow, then you can just look at the yellow all the time, which is the pool estimate, and you see that some regions like Balearics and Madrid, Navarra, Basque Country, and Catalonia tend to stand out from the rest. Also Cantabria, as you see there. And this is telling you that they have a differential effect. They have an effect that is specific for the region, and that is that they have something, some kind of difference that makes the people in that region behave differently. Then if you look at yearly dummies, we find something similar in the sense that it is the effect of the year is increasing over time, and once it is increasing over time, you see that it is quite big for the years 15 and 17, and what that is telling you is that there is something in the relationship that is not captured by the individual effects and by the individual variation of the explanatory variables that is still going on an aggregate basis. And that can be thought as the supply side effects. So the supply is changing a long time, and those changes do have an effect on the behavior of the population, and in particular, the supply side changes interact with the demand and are contributing to the increase of the total use of e-commerce. The previous results are interesting, but they are centered on, say, a decision of whether to use or not to use e-commerce. It is important also not only to the decision, but also how much people spend in e-commerce. And it is important because we are economists, we care about what people actually do and spend, and this is a very important dimension of the problem here. The expenditure here is divided into 5 levels because those are the data that we have in the sample, and it is an ordered logistic model. The dependent variable is whether the expenditure is very low, medium, high, or very high. So now the dependent variable has like 5 different values, 1, 2, 3, 4, 5, but the differences between 1 and 2 and 4 and 5, say, did not be the same. So the cutting points for these categories are not clear and they are not known. They may have to be estimated. The expenditure in e-commerce, we have both a pool and a panel model. We only have 3 years of pool and 2 years of panel, and that happened up to 2017. Now we will have more than that. We have models that are highly significant also. We have 10,000 observations for the pool, and we find a positive effect of variables like male, age, education, digital skills, employed, income, and especially high income. We also have a negative effect for household members and being Spanish. And again, we have an insignificant effect of the variable habitat. We have differences in node ratios that are less intense than in the adoption model for digital skills. And again, some of the communities stand out, like Baleares, Cantabria, Castilla-La Mancha, Galicia, Navarra, and the Basque Country. So we do have another additional model for expenditure, which is in the same spirit as before, but it has a different dependent variable and of course different coefficients and different effects. So now let's jump to the conclusions of this paper that I'm talking about today. And this is the first time to use this type of data in Spain, especially in the panel data. The first time to use panel data techniques, and then we can find from there consistent, efficient, and robust estimates. We have seen that not all variables have the same type of effect. Some of them have like negative effects, female, unemployed, retired, housekeeper, rural areas, and over 55 years. And we have been using panel data and controls for individual. We have used a random effects model. The effects of the determinants for adoption are larger and more significant than in the pool case, and in particular, gender, income, age, digital skills, and education, larger and more significant. High digital skills also have a positive influence, and a clearly positive influence on the income and the decision of choosing or not choosing to buy through e-commerce. Now let's talk about the policy recommendations, because all the papers have to have in mind that it is the focal point is the policy recommendations. If you don't have policy recommendation, if what you are studying doesn't have any practical implication, then it is useless. No? So we need some policy recommendations to show that we have done a useful work. And the idea first is the policy recommendations are um, directed to promoting e-commerce because e-commerce is very low in Spain and the European Union have been calling all the time the attention on this issue. It's too low. And then the demand side would be try to bridge digital divides. So to promote e-commerce, we are going first to look at the demand side, then to the supply side. First, the demand side is how to influence the buyers. And the idea is that it is necessary to set up policies that focus specifically on females, people over 55 with low digital skills and living in rural areas and housekeepers. That would be the typical prescription in this area. And you have to notice that there are some initiatives along the lines, as I will mention later. You have a technical support line, and that would be very useful. Some people are already using this for private purposes, but it would be very useful to have a technical support line for people, who do not have that much digital skills. And then training on specific digital skills would be very useful, and focusing on the effort of going from low to medium level digital skills. All these initiatives have been partly undertaken already, so they are not impossible, that they make sense from any point of view. Now let's look at the supply side measures. Supply side measures are also very important. The government has to do its part, like promoting complementary services, e-government and e-health, identifying and re-editing successful supply side programs, reducing transaction costs. So it is important to see that the red tape, so the bureaucracy, has to be brought to a minimum if people wants to be forced or pushed towards doing e-commerce. And also, it would be nice if the government would implement some incentives for efficient e-commerce platforms. So those are duties that the government can do and should do for promoting e-commerce. Now, the private sector also has things to do, and it would be very nice also if they would use easy-to-use platforms, like things like Amazon or things like that. People should be encouraged to implement platforms that are easy to use, are user-friendly. And it would be important also to ask for customer reviews. Some platforms do this, most don't, and they are very good for improving the confidence in e-commerce. And then streamline payment and transaction processes. That would be also very useful. And that's all for the moment. Please notice that you have an appendix there in your PowerPoint presentation, and there are limitations, further research, other results that I haven't talked to you yet, other graphs that may be useful or not. So the models estimated, say, only for Madrid, relationship between Spain and Madrid. And then want to point out about our previous papers Garín and Pérez Amaral, Garín et alia, Valareso et alia, and Correa et alia. And those are important papers if you want to look at them. And then you can see here what are the references of these papers, which are in your transparencies, and you may want to look at them if you care about these issues. Okay.